Okay, we started talking last time in section 7.4, and we had done the first half of this lesson, which is on percent. And what we're going to do today is on interest. And obviously these things are related. That's why they've put them into the same section. But there's some differences as well. So we're going to take a look at interest. I did that one. All right. So some interest applications. As we do applications in this section, we're going to need to talk about what interest is and how it's calculated. So first of all, interest is the amount of money that you pay or earn to borrow or lend money. So a couple of things. So you put money in the bank in a savings account or in a CD or something like that. The amount of money that you earn from leaving it there is called interest. But also if you borrow money for a house, for a car, on a credit card, that's also called interest. It's the amount of money that you pay for the benefit of them having given you money that wasn't yours. All right, so that's both called interest. Principal is the original amount that's used to determine the interest. So if it's the money, if it's interest you're making on the account, it's the money you put into the account. If it's a loan, it's the money you borrowed or that you still owe, depending on the situation on the account. Okay? The interest rate is the percent, there's that percent, that's used to determine the interest that you're making or you're paying. And then there are two types of interest. The first one is simple interest. You see two formulas there. They're very related formulas. There's nothing really all that earth-shattering about them. One of them factors the p out and one of them distributes the p through. All right, it's the same thing. The second one is compound interest. And you see some language there for that one. All right, there is a note here, and it is really important. The formula that I'm giving you for compound interest is not the one that your book uses. And the one they use is totally appropriate. There's nothing wrong with it, except that it's not the one that's commonly used. It's not what you're probably going to see in a textbook if you're teaching something about interest. This one is much more likely to occur. I'm not sure I've ever used a textbook besides this one who uses that formula. So that's how I would say uncommon it is, okay? So let's talk about what some of these letters are. And I'll bet you can identify some of them, and you've probably seen others of them enough that you remember them. So let's start with P. Do you know what P is? That is the principal. Principal is one of those words that I never know if it's A-L or L-E at the end on this particular one. Apparently it's A-L, like the PAL, the principal at your school. All right, any idea what R would be? Right, that's the rate, the interest rate. It is important to note that this is as a decimal. Okay, so if it's 4.2%, that's a percent, right? We don't put in 4.2. We have to turn it back into its decimal form and use it from its decimal form. Okay, that's really important because you'll definitely get things all mixed up if that happens. Any idea what time is? Times T, yeah. I didn't say that right at all. How do you think time is calculated? How about that? It's a good guess. Months, years, which one do you think? The percentage rate isn't a per year rate, that's true, because the time is given in years. So the time will always be given in the formula, the time given is always in years. So let's say, for instance, that you're doing a problem and it says the time is for 6 months. You don't put a 6 in for T. What would you'd put in a 0.5. Yeah. So keep that in mind because that's really a quick way to just make an error. I mean, just because you're seeing a number already, just use it as it is. Make sure you're putting in T for time in years. All right, I think there's only one letter left, N. And it only occurs in the second one right here, right, for compound interest. Does anybody remember what that N is?
How many times it's compounded?
Very good, in a year. So this is the number. I like you how you said it better, but I'm going to write it the way that I always write it, okay? And then I'll re-say it. The number of compoundings per year. So if you have something compounding monthly, how many times in a year would it compound? 12. So N would be 12. If you had something compounding weekly, you'd have 52. Daily, 365. What if it were, let's see if you know this one, because this one always trips people up, bi-weekly. So is it 104 or is it 26? It's one that's a little awkward. It's actually 26. Bi-weekly means every 2 weeks. Yeah. If you had semi-weekly, that'd be 104. We don't actually hear the word used, but you hear them used for like biannual sale and semi-annual sale, those kinds of things. So, yeah. All right, so let's see. Sometimes you hear quarterly. What would quarterly be? 4 times a year, right? That one's a really common one, actually. Quarterly and monthly are probably your most common ones. What if it's just said annually? That's once a year. So you'll hear that one as well. Those are probably the 3 that occur the most frequently.
So what does that mean?
Compounding means the number of times it compounds. So, like if you have something, let's take something like a loan at a bank or a credit union, like a car loan. The way those usually compound is monthly. So at the end of the month, they look at how much money you owe them, and then they calculate the interest based on that particular amount that you owe them right now. So that's how they compound it. They compound it every month. They calculate the interest. Okay. Now it doesn't have to be monthly. I mean, it could be at the end of every quarter, and they compound the interest. So sometimes you'll see banks compound your savings account quarterly. Only once every 3 months is what that would actually be. But then they want to charge you interest monthly, right? Because that makes them more money, actually. So something to keep in mind. One caveat to doing this, and I know you see it, but because of the way calculators work, it's easy to just not think about what you're doing. Notice that that exponent is the n and the t, and those are actually, okay, so notice that the n and the t are both in the exponent. So what that means is that those have to actually be multiplied together before they're applied to the value before. So some of you have the calculators like the TI-84s, that kind of calculator, or even if you don't, if you're not careful, and you're putting things in a way that doesn't include parentheses or something like that, it's really easy for your calculator to think you want to raise it to the first power, and it gives you an answer, and then you multiply that answer by the second value, which was not what you meant to do. So calculators are a little bit finicky because all they can do is what you tell them to do, and if you're not extremely explicit, they might not do what you intended. So we'll be really careful when we calculate things so you can see when and how that actually messes up, okay? All right, so let's do an example. I have a company and it's expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual interest for a period of 18 months. How much interest will the company be charged? What if they charged 13.5% compounded monthly? All right, so the first thing that we have to do is we have to decide which formula. And I always have students struggle with this, but without fail, it's already telling you in the problem which one to use. So it's really just a matter of reading carefully. So the first question that we're asked tells us that we're finding simple interest. Like it tells you which one to use. So the simple interest formula is A equals P times 1 plus RT. Or you can use the other version of it if you like it better. It doesn't matter. And what we're tasked with doing here is figuring out which of the letters we have and where they go, and then calculating this amount. Now, we have to be careful we answer the question that's asked at the end, so we'll have to come back to that problem in a moment. But first, we need to figure out where things go. So, P, principal. What is the principal in this problem? Right, it's the amount of money in this case that we're borrowing, which is quite a lot. $320, at least that's a lot in terms of, what I think. $320,000. Have 1 plus. What is R? Okay, it's this right here, right? It's the 13.5%. Yeah? That's my percent, my rate. But I need to convert it, and some of you are already doing this and some of you weren't, so why I'm specifying this. I need to convert it into a decimal. So what would 13.5% be in decimal form? That is 0.135. And that's one of the things that we worked with last time. One of the ways to do that is to simply take the decimal point and you move it 2 to the left. Okay, so the 0.135. The next thing it tells us is that it's supposed to be for a specific length of time. And the time says 18 months. So we write 1.5 for the number of years. Very good. You'll notice I double parentheses some things. I just did that because I don't want I use a dot between things for multiplication, and I don't want that dot to look like a decimal point. So that's the only reason I did that. All right, your calculator can handle this just fine if you put it in exactly like it's written. If you don't have a calculator that likes parentheses or wants to work with parentheses very well, you can work from the inside out, which means you would multiply the 0.135 times the 1.5, hit enter, and then do plus 1 and hit enter, and then do times the 320,000 and hit enter. So working from the inside out. Order of operations, basically, right? Okay, either way you do it, you find out that you have an amount of what? Okay, 384,800. So they borrowed 320,000. They're going to have to pay back 384,800. And the question that was asked was not how much they're going to have to pay back, though. What is it asking me? How much interest is charged to them? So what will their interest be?
That minus the principal amount.
Right, the interest will be the 384,800 minus the 320,000. So what will the interest be that they are charged? $64,800. Really hope it works out for them. Yes.
I use the other formula.
Yes. Hold tight. There's a reason why. I'm going to show you why in a minute. I know exactly what you're about to ask me, Andrew. And you're right. Is that okay?
Yeah, go ahead.
Okay. I want to show it from this way because of the other part of the problem. Okay? But I will come back to that. So if I forget to come back to it, remind me again. All right? Okay. The other part of the problem asks, what if we do the same thing but it's compounded monthly? You guys with me? Okay. So if we do this and it's compounded monthly, we use a different formula. Agreed?
Yes.
Okay, so I hate that I'm about to erase this because I feel like that's inappropriate, but I need a little bit more space and I didn't plan very well apparently. You guys all have it written down yet anyway, right? It's all good. All right, so we've got A equals, we have P times 1 plus R over N to the NT. Okay, the P is the same as before, 320,000. What is R again? 0.135. Okay, N we haven't discussed yet. What would N be now? No. Good try. I know why you're saying it, but think again. It'll be 12. The thing you have to be careful of in the problem where we're working is that N is the number of compoundings per year. It's always in a per year amount. So the fact that they said monthly is going to give me the 12. It's not the actual number of compoundings, which would be 18. It's just the number that occur in 1 year time span. It's a little tricky that way. And then over here, of course, that gives me that same 12 that I had before. And I have the time, which is 1.5. And I'm running out of space, but you probably aren't. 1.5. Here's a cool thing. Take a look at that exponent. What happens when I multiply the 12 by the 1.5? I get the 18, right? That's not an accident. It's actually the 18 because it's the number of compoundings times the number of years. So this is the actual number of compoundings total. 18, because it's 18 months that it's going to compound for. So that always happens. So if we're taking a look at simplifying this, I have 320,000. And I have 1 plus, and you can simplify if you'd like, 3/5 over 12. And then we really should think through and write that as an 18. That is the best way to avoid calculator error with parentheses, is to just multiply the exponents together. Then we don't have to worry about where we put our parentheses or being careful that the calculator interprets to multiply the exponents before it multiplies by an exponent. That's not what we want. And so this is the easiest way to avoid it. All right, so grab your calculator. Again, if you're working with a calculator that doesn't work with the parentheses very well, you're going to take what's inside the parentheses, do all of that, hit enter, raise it to a power 18. That's the next thing. And then the last thing you would do is the multiplication by the 320,000. Okay, we work inside out. Parentheses inside, you do the division, the addition, and then the exponent, and then you do the multiplication on the outside. If I do this, what do I get for the amount that he is going to be charged? Oh, I didn't write this one down.
391,384.48
Okay, so we're going to write the change down. So then his interest would be what? Yeah, I think 320. I think I'm hearing you guys right. So this would be 71,384.48. Yes? Okay, so a couple of things to note. Issue number 1, which one ends up charging more interest? The compounding one, right? The simple interest charges less interest, compounded interest charges more interest. Something to be aware of, okay? The second thing to be aware of is what Andrew was trying to tell us before. With the first formula, there is actually another way to do this problem. There is a direct way to do it. If you take a look at the other formula for interest, right here, that's the $320,000, right? That's the original amount. And this is actually the interest. You could calculate the interest directly by just calculating the P times RT part of it. You don't need the other piece. The reason I bring this up is because you can't do that with the other formula. It doesn't break apart in that way. You actually have to calculate the total amount owed and then subtract the interest. Has to be done in that way. So while this is totally valid and it totally works for the first option, since it doesn't work for the second option, I tend to work with it in the same way and calculate amounts and then subtract off original values. Not because I have to, but just because it works for both of them. Does that make sense, Andrew? Yeah? But it works. So if you want to calculate the first one with the interest only part of it, you can. All right, let's take a look at another problem. Johnny and Carolyn have 3 savings plans that sum to the following interest in 1 year. They have a passbook account that made $53.90, principal of $980, a CD with $55.20 on a principal of $600, and a money market that made $158.40 on a principal of $1,200. The question is which account paid the best annual interest rate for 1 year? Now, this problem actually makes it look like it's about interest, like the interest formulas that we were using, and it actually isn't. Because they're asking you about what percent of something happened, right? They're asking you for a percent rate. So take a look back over here when we dealt with this last class period. There are 3 types of percent applications. And one of them, namely number 2, finds a percentage when a portion of a percentage is known. You guys see that? So even though this question is about interest, I mean, it is really about interest, because it's finding a percentage and interest rate, it actually is more like this particular problem than the other ones. So what we're going to do is we're going to attempt to solve it in that fashion as well. Okay, so we have our passbook account, number 1, and they make a certain amount of money, and we can work with this in a proportion form, just like we did last time. Okay? Our question is to find the percent rate, that is x over 100. What percent out of 100? So the value that goes on bottom would be what for problem number 1? 980, yes, thank you. What value will go on top? 5390. Okay, 5390 is the amount they made on the original amount, the 100% amount of the 980. And then we can cross multiply, right? So we have 980x equals, and it's actually 5,390. And we'll divide by 980. What do you get for your percentage here? I should make note of the fact that it's going to be giving you a decimal. What is the decimal that it gives you? 0.55? Exactly, or more after that? That looks, it's exactly 5.5? 5.5? Okay, so it gave you it like this? Awesome. All right, good. I'm sorry. I probably said that a little bit incorrectly. Yeah, it is going to give you the percentage rate because we're actually writing it as a value over 100. I wrote the 100 part, so I forgot about writing that in that way. Yeah, so this is a 5.5% interest rate on the passbook account. Okay? We're ready to do the CD. CD. What will the proportion look like? Same thing. So what's going to go on top, Haley?
55.
Good. Someone else, what's going to go on bottom? 600. And what's going to go on the right-hand side? X over 100. Exactly. We're going to cross multiply. We have 600x equals 5,520. What does the percent equal in this particular problem? What was it?
9.2.
9.2, and again, it is a percent. We have one more account, account 3. It's a money market. what will the proportion look like here? The same thing, 158.40 over 1,200 equals x over 100. And we will cross multiply. So I have 1,200x equals 15840, so 15,840. And we divide by 1,200. What does x equal on this one? 13.2. Is that right?
Yes.
Percent. Okay, so this is the work that's going to support the answer we're about to give, but we didn't actually give the answer yet. The question asked, which account paid the best annual interest rate for 1 year? Account number 3, right? Or the money market account. So our answer is the money market account. Please make sure you answer the question that's asked, okay? Because they likewise could have asked you something quite different, like which account would you get rid of if you were Johnny and Carolyn? Right? I mean, like that could be the question. So make sure you're answering the question they ask. We're going to do another question that doesn't even look like it's interest, but it actually is, which is sort of a little bit strange, okay? But taking a look at this one, we're going to take that same approach. It says, if a publishing company signed an agreement to allow a textbook, the first edition of the textbook has 500 pages, to expand over several editions to 1,000 pages, and the book is growing at approximately 10% in the number of pages over each edition, how many editions could be published before it reached the contractual limit? Okay, so just to get a handle on what's going on, the first book that they've produced is 500 pages. What would you do to figure out how many is in the second book? 10%. So what's 10% of 500? 50. So how many pages would be in edition number 2? 550. Okay? Are there going to be 600 pages in edition 2 or 3? No, it would be more, right? What would we have to do to find the following edition value? 10% of 550. Okay, so think about what's happening. You're going to find a percentage based on a new value every time, right? That's compound interest. Compounding does things based on what the new value is. Okay? This is what happens when you have a loan or if you have money on credit or money on like in a savings account at a credit union. The interest is paid on what you currently have or you currently owe right now. Okay, so this problem, even though it isn't really an interest problem, it is a compounding problem that works like interest. So let's see how this works, okay? So let's take a look. We have our first book. And like we said, it's 500 pages. Now, I'm going to do a couple of things with you. We're going to write down what our second book is, the way that you guys kind of structured thinking about it. And then we'll see if we can write it in a way that's a little bit more helpful for us, okay? So it was 500, and then you multiplied it by 10%, which means you really multiplied by what decimal? 0.10. And then you added to it what? The original 500, right? Right? 10% of 500 would be the 50, and you added the original 500 pages. Is there a way to write this in a little bit more of a condensed form? It looks a lot like that one formula we had, didn't it? Mm-hmm. There's a 500 there twice, correct? It would actually be a lot easier, and I know we're not really doing algebra per se in this class so much, but it would be a lot easier if we factored the 500 out in front and thought about this 10% right here with this one that I'm not really seeing right here, so that this is actually 1.10. The other thing that you could think about when you're thinking about that 1.10 is that's 110%, right? 100% because that's the original size of the book. 10% because that's the increase in the size of the book. Are you with me? Okay, here's why this is helpful. Take a look what happens on the third book if I approach it from this angle. If I approach it from this angle, I can take that same 500 times 1.10, and instead of finding that value and finding a percentage of it and then adding something else to it that was dependent on the last part I just did, I can square it. Does that start to look like that compound interest formula again too? Where it has that exponent on there? It does. So that's my third book. My fourth book. What would the formula look like if we're going from this approach at my fourth book? It will be cubed, exactly. Okay, we're going to take a look, a couple more to getting through this. We're going to keep going. So I want us to actually find some of these values. The fifth book, what would that one be? Yeah, power 4. Okay, let me pause for a second. Let's go back and get some values. Now, we already told, just a moment ago, I'll write these in blue just so that we make sure we see that that's the value we care about, really. We care about that it was 500 pages, it was 550 pages. Okay, so somebody, I want us to take a look at the 550 and then the book after that, the third edition of the book. How many pages would be in that edition? And we're going to round to a whole page number, by the way. So if things come up with weird decimals, just whole pages are fine. 605. Okay, great. How about the next one?
665.5.
Okay, so 666, right? If we were to round?
Yes.
Okay. Not our favorite number, maybe. Okay, what about the next book? How much? I think I heard it. 732. Thank you, Selena. Okay, now some of you are getting the answers very quickly, and others of you, I can tell, are looking around going, how'd they get the answer so fast? So how can you get from one answer to the other one faster? Just times your last answer by 1.1, right? Okay, so you don't actually have to type everything in all the way again, correct? You just times 1.1 to get the next one. So let's actually finish this out. I'm not going to write them all out. I'm just going to write the answer. What if I have my sixth book, so 732 times the 1.1? 805, good. How about my seventh book? 886 or 885, depending on your rounding. Not going to be too much of a stickler on it. Either way is fine. How about my eighth book? 974. And what happens if I try to make a ninth edition of this book? It's over 1,000. What is it? What's the actual value it gives me? 1,072. So my contractual limit has been reached. I only get to make up to 1,000 pages in my book. Okay? That's what's going on. Now let's go back and look at the particular problem. The question actually asks us how many editions could be published before it reaches its contractual limit. And if we've kept track in a detailed fashion, which we did on the board, right? Hopefully you did in your notes. The answer's already done, right? How many editions will we get to make of our book? 8 editions. We'll get to make 8 editions. All right, I think there's one last question, right? This is one of my favorite questions because it is intuitively not the result you're expecting. Okay? So it says because of a recession, you guys know what a recession is? Like where the economy goes down, a recession. The value of a new home depreciated. That means it went down by 10% each year for 3 years in a row. Then, for the next 3 years, the economy began to recover, and the value of the house increased by 10% per year. Did the value of the house increase or decrease after 6 years? So some people would look at this problem and they would say it does what? What does it sort of look like on the surface happens? It stays the same. That's what it looks like, right? I mean, it went down 10% 3 times, it went up 10% 3 times. It's the same amount of the value of the house. So we're going to actually do the math to show that that doesn't work. But there is a catch to this. The catch is nobody told us how much the house cost, right? So what that means is that it doesn't really matter. It could have been anything, and the result's going to be the same. That's why they're posing the problem the way it is. So we're going to pick an amount for a house that's easy to work with. 100,000. That's what we're going to pick is 100,000 because it's a nice whole number. It'll be easy to compare things to at the end. Don't make it hard on yourself, okay? $100,000 is a good place to start on this. So we're going to say that our original price of our house is $100,000. That is actually very close to what the cost was of the first house that my husband and I owned, $100,000. Awfully close. I think it was just a touch over like 105 or something. All right, so it's going to go down 10%. So, oops, let me write it differently than that. So this is year 1. And it needs to go down 10%. Okay, so thinking about what we did in the last problem, when we wanted it to go up by 10%, we multiplied by 1.1. Because that's 10% more, right, than it was before. What are we going to do if we wanted to go down by 10%? Point what? We're not going to divide, but that's a good thought. We're going to multiply by something, 0.9. So why not 0.9? Well, because it's 90% of what it was before, right? So on the last problem, it went up 10%. That's 110%. Now it's going down 10%, so that's 90%. So we're going to take my 100,000, and we're going to multiply by 0.9, and that's going to give me the cost of the house after it went down the first year of $90,000. That's what it's giving me. What would I have to do for the second year? Squared, exactly. I can do the same thing, just multiply by 0.9 again. Now, practically speaking, there's no reason to do that in your calculator. You can just take what's in there and multiply by 0.9, and it'll give you what? Should give you 81,000, does it? Awesome. Excellent. Okay. We're going to go down one more year. So I've now got my 100,000 times 0.9 cubed, which is the same thing as the 81,000 times 0.9, right? Which gives me 70 something. 70 what? 72,900. Notice, do you know what special pattern is happening here? Sequences and series sort of stuff? Like, some of you have had elementary math 1 last semester. Do you see powers going on here where you're multiplying next? We called it a geometric sequence back in the day. Yeah, it's a geometric sequence. If you don't know what I'm talking about, don't worry, you'll get there. All right, so at the end of the recession, the house is worth $72,900. And if, I don't know what their names were, it doesn't even say, let's call them JoJo. If JoJo and Gigi, I actually know a couple, and that's what they're, what people call them, JoJo and Gigi. If JoJo and Gigi did this, then they probably don't owe just $72,000 on their house. And that's where you saw a lot of people have problems during the economic downturn a little while back, is that they probably owe something like $80,000 on the house, and it's not worth that now. Luckily for JoJo and Gigi, they've got 3 more years, and it's going up this time, right? Okay, but the amount that it's going up is based on the amount that we're starting at when it goes up. So the starting value now for their house is what? Yeah, the $72,900. So now it's going to go up by 10% a year. So what am I going to do for that? Right, 1.1. So what happens when I multiply 72,900 by 1.1? 80,190. And we'll still work with whole values. We're going to hit some decimals here in a moment. But honestly, decimal values in the price of a house is kind of a silly thing to talk about. So we're just going to go with the whole number amount. All right, we've got 2 more years to do. 5th year. What would we do for our 5th year? Yeah, we're going to multiply that same 72,900, but it'll be by 1.1 squared. Or equivalently, we can talk about multiplying the 80,190 by another 1.1, which gives me what? 88,209? Yes. Okay. Awesome. 1 more year for it to recover. 6th year. Same 72,900. The same 1.1, and now it's cubed. How much would we get during the 6th year, or after this has happened for 6?
97,029.
Yeah, that's close enough. We're not going to worry about decimals. Yes, Lauren?
I guess I just don't understand why we're using 1.1.
1.1 is the original price. 100%, that's the 1. The 1 in the 1.1 is the 100%. And 10 is the 10% of the increase. The problem up here said that it's increasing by 10%. So that's where that 0.1 is coming from. And the 1 at the beginning is coming from the original price of 100%.
Okay.
Yes. Good question.
Basically saves you from adding that regular value.
Yeah, it saves you a step in the addition. It saves you from having to do a multiplication and then add the original value. That's exactly right, Andrew. All right, so first question asked, Part A. Did the value of the house increase or decrease after 6 years? It did. It decreased. My answer is decreased. It decreased after 6 years. Now, the more interesting idea is that we did this sort of a weird thing where we picked the value of our house as $100,000. So on part B, it wants to know what in the world, by what percent did it increase or decrease over the 6 year period? So how would I find that?
You just find out what percent.
Right, and we did some problems like that before, right? As proportions. I'm looking for a percent. Now, let's pause for a moment and figure out what's going to go where on the left-hand side. Because the problem's not posed quite like we had before.
72,900 is the bottom number.
It is a value in the problem, but it's not the value in either part of the left-hand side.
When the original price of the house came.
Okay, so what was the original price of our house? Okay, so our 100,000 is on the bottom. We want to start with the actual original price of the house, so that's the 100,000. So it goes down to 72, but that part is not the original price of the house. We want to use the 100,000. What will we use on top? So we have two choices here.
If you subtract the 97,000, then you need to find out what
The
it
amount
is.
difference between that starting value.
Yeah, you guys are saying the same thing, exactly. So the question is asking us about the percent of the increase, right? The percent of the increase or decrease, not the actual value. So let's take a look at the actual change in the value. It started at 100,000 and it ended at 97,029. So how much did the actual value change?
2,970.
2,970. Does that look okay, guys?
71.
71. Oh, you're right, yeah. 71. So that's the change in value. That's what I'm going to put on the top over here. Now, let's pause for a moment for those of you who were looking at this and said you would have put the 97,000. That's totally fine. It wouldn't hurt anything. It just means at the end, you're going to have to interpret what you've done in terms of the context of the problem. So it's just that one interpretation step at the end to realize what it's actually asking, okay? So as we solve this then, we're going to cross multiply. So I've got 100,000x equals 297100, and then we'll divide by 100,000. And this is going to give me a percent. What? Yeah, 2.971 or some variation of that. You probably would see it written as 2.8 or 3.0 probably if you were rounding, but this is fine. Yes, Lauren?
Okay, I just realized, I was looking, did we just, make up 100,000?
We did.
Okay.
We totally made it up. You're exactly right. And if you had been doing the problem on your own and you made up 150,000 or 40,000 or $10 or whatever,
Okay.
it would still work out the same way in the end. All the math works out nicely.
Okay, I was like, wait.
Yeah, 100,000 was just totally a pick.
Okay.
Yeah. Any other questions on this one? All right.